Okay, a few things we're going to do today. The first thing, I'm going to go to my course docs and links. I'm just going to show you a PowerPoint really quick, and you don't have to open this. This PowerPoint that I put on here more or less summarizes, it's called Transformation Basic Rules. And since I put so much work into making this PowerPoint, I have to show it to you. But you can access this at any point if you need a little refresher on it's kind of a summary of like what you guys typed into like step 8 and step 12 and whatnot on the Desmos the other day, indicating like the rules and the observations that you made. So transformations, that's the wrong, not 2.5, it should have been 3.5, right? Yeah. Okay, so if you want to transform your graph in a left-right manner, left and right, okay, there's multiple ways that we could do this. Maybe we just want to shift it left or right. That would be like the rigid transformation that I was just talking about, where we just pick it up and we move it. So we could shift it left or right. We could reflect it, and I'm talking about reflecting it over the y-axis. So our y-axis is the vertical one, so if it's sitting here, it's like turning the page on a book, you reflect it over the other way or back and forth. That would be a horizontal transformation. If you wanted to stretch or shrink it, we could grab it from the left and the right and we could stretch it out, or we could push on the left and right and we could squish it. That's a horizontal, right? If you want to do any of that, notice that it's a left-right, horizontal. You have to manipulate x, the input, our independent variable. Okay? So I want you to pay attention to the words up there that are in red, because you can already probably predict what my next slide is going to be. Okay? If you look at the red, left, right, flip over the y-axis, horizontal, and x the input. Okay, so x is your left-right axis. Now we're going to go up-down. And it's just going to be the exact opposite of slide number 1. If we want to do up or down, maybe we pick it up and shift it up and down. That would be a rigid transformation. Maybe we want to reflect it over the x-axis. That would be a vertical transformation. Stretch or shrink it vertically. I can grab it from the top and the bottom and stretch it. Or I could grab it or push down on the top and the bottom and compress it. And we talked about this the other day. Compressing it vertically often has the same effect as pulling it horizontally. Does that make sense? Or stretching it vertically has the same effect as squishing it horizontally. And that can get a little dicey trying to understand the difference between those two. If you want to do any of that, you don't manipulate x, you manipulate f of x after the parent function has taken place. Okay? So the y or the f of x axis is the up-down axis. So manipulating x means that you add, subtract, multiply, divide something by some value before any other action takes place within the parent function. So x is before. F of x or y, you do something after the parent function has taken place. So I put a parent function up on the top here, and I put in letters a, b, h, and k. Those are variables. Those could be any numbers, right? Can you guys see which ones are manipulating x before the parent function and which ones are manipulating after the parent function? First of all, who's my parent? Squared, x squared. So the 2, in my order of operations, whenever the square happens, that's the line from the before to the after, right? That's the parent function. So out of a, b, h, and k, which ones of them are manipulating before the square ever happens? B and H, right? This B would compress or stretch X. And H, we already know, is going to do what? Shift it. pick it up and move it. After B and H are done doing whatever they want to do, then order of operations says we're going to square it. That's my parent function. Okay? After the parent function is done, who gets some action here? A and eventually K. What's A going to do? Vertical stretch or shrink. It'll stretch if it's larger than 1. It'll shrink if it's less than 1, right? And if A is 1, it has no effect whatsoever because anything times 1 is just himself, right? Same thing with B. If B is 1, it's like it's not even there. But if it's smaller than 1, that has an effect. If it's bigger than 1, that has an effect. And then, of course, K, our very last thing, that shifts it up and down, right? Okay, so let's practice something here. I want to go to 3.5 transformation example GeoGebra. Do you guys see it on your course docs and links? 3.5 transformation example.ggb. I'd like you to open that. Should look like mine when you get it open. What we're going to do is those 5 blue points, we are going to move those 5 blue points. Let me make my font size a little bit bigger for you here. Okay. So I gave you this goofy looking function, and I'm just going to, it's the one with the red lines here. I'm just going to call it f of x. Okay? It's not a parent function that you're going to find on that sheet that I showed you the other day. So if this original one, the one that is right here, is f of x, the goal is to produce the child, and the child is this guy. So, if I want to produce that child, let's do this together. I see a negative half out front, I see a 1 on the inside, and I see a minus 2 on the outside. Order of operations, who's going to act first? Out of the negative half, the plus 1, and the minus 2. The plus 1, right? The plus 1 is inside the function. Notice I'm adding 1 onto x before f. F is my parent function. Before f even takes place, right? So plus 1 is going to cause me to do what to my graph? Move it over to the left. How many units? 1 unit. So what I'd like you to do is grab your pointer tool, and I want you to move this whole thing over to the left 1 unit. And we're going to do that by moving the 5 blue dots. So this one is currently at negative 4, 0. So where am I going to move them? Over to negative 5, 0. This one's currently at negative 2, 4. So he's going to become negative 3, 4. Move every dot 1 unit to the left. It should kind of suck it into the point there. It locks in. If you guys figured that out. Did you get all 5 of them moved? Does your graph now look like mine? And are your 5 points the same coordinates as my 5 points? Okay, so that wasn't rocket science. We just moved it 1 unit to the left. So I've tackled one of my transformations. But there's multiple ones going on here, right? What's next? Yeah, the negative 1/2. And let's break that into 2, just so we can feel it. Let's call one of them the negative sign and the other one the half. We'll do one at a time. Let's do the half first. Ignore the negative sign just for now. What does the half do to my graph? Vertical shrink or compression, right? Every dot, his height is going to become half of what it currently is, right? Half. So let's go to my first dot again. The height of my first dot is 0. What's half of 0? 0. So I'm not going to move him at all. Does that make sense? Half of 0 is still 0, so I'm going to leave him. This guy has a height of 4. What's his new position going to be? 2. His height needs to move down to 2. Now I'm not going to change his x, just his height. So his height got cut in half, right? This guy is 0. He's going to stay at 0. This guy has a height of negative 2. What's his new height going to be? Negative 1, because half of negative 2 is negative 1. And this guy is 0, so I'm not going to move him, right? Okay, so I'm done with the half. Now let's go to the negative. I'm going to take the height of every dot and I'm going to flip it or make it negative, right? So this guy has a height of 0. What's negative 0? 0. He's not going to move. This guy has a height of 2. What's his new height going to be? Negative 2. So I'm going to move him down there. 0 again, negative 0 is just 0. This guy has a height of negative 1. His new height is going to be positive 1, and 0 stays 0. All we did is we did one of those, right? We flipped it over. So we're almost done. There's only one transformation that we haven't done yet, and that's the minus 2. What kind of transformation is that going to be? It's rigid. We're done changing the shape of it. We're just going to move the whole darn thing 2 units down. So this guy is going to become negative 5, negative 2. This guy's going to go down to negative 4. This guy's going to go to negative 2. This guy's going to go to negative 1. And this guy's going to go to negative 2. Whoops. And I should be done. I now have my child. Not too bad? Comfortable? Okay. I'm not going to have you turn that in. That was just for practice. You can get rid of that. Or you can save it. Whatever. I'd like you to try, you guys know how much I love marble slides. Who likes the marble slides? Be honest. About half of you. Who dislikes the marble slides? Okay. I saw more likes than dislikes. We're only going to do 4 of them. We're only going to do 4 of them. Do you guys see marble slides complete through fix-it number 4? Go ahead and go there. I think the marble slides are fun. 1 or 2 of you already worked on this. So if you did, you can go beyond number 4. There's a lot. You can practice as much as you want. I want us to get through the first 6 steps, which is fix it number 4. So let me sign in so I can view who's in. We are on marble slides. It's actually marble slides parabolas. So what are you doing in order to make your marble slides work? There's a lot of things you can do. You can do transformations. You can limit the domain if you want. Remember how we learned how to cut the domain off or extend the domain? You can add a second or a third line. So you see these guys here, they have 3 different ones on their example. They have 3 different something going on there. So they're giving you, in step 1, they're giving you a quadratic, just like we were working on earlier. Notice the only one that they don't have in there, and you could put it in there, they don't have the B. See how I have B up here? Otherwise, they have the A, they have the H, and they have the K. If you wanted to insert a B in there, you can. But remember, the horizontal shrink and stretch largely can be done with a vertical shrink and stretch. So you don't necessarily have to have both the A and the B. You can kind of accomplish what you want with only one of them. So give it a run. See if you can manipulate it. I see lots of you have already accomplished fix-it number 1. There's this cool thing where you can plug your computer in and it charges something called the battery.
Yeah, I know.
And then the battery...
I did charge it. But apparently it came on loose.
Okay.
So...
Okay. Now, if you get past fix-it number 4, I see some of you already are. Just go ahead and keep going if you want. Let your classmates catch up with you. See how yours is this way?
Mm-hmm.
I don't think you're ever going to get it.
Okay.
Because the stars are shaped more like.
Mm-hmm.
So how can you flip it? So instead of being like this, you can get it to go like this.
Negative.
Yeah, exactly. Try that. Now you got to move it. Yeah, very good. Like the shape of the stars kind of gives you an idea.
Mm-hmm.
You want to be an egg, Jeremy? What? You want to be an egg business in the 1800s?
See how yours is shaped like this? Mm-hmm. But the stars are kind of shaped like this.
Oh, okay, yeah.
So,
I see now.
so how can you fix your...
Flip it.
Yeah, how do you do that? That 0.1 that you've been fiddling with there?
Oh, make it a negative.
Make it a negative.
Okay.
Yeah. And now you'll have the right shape. Now you just got to move it.
Okay.
There you go. Yep. Yeah.
That's nice, guy. Can you just say go through 4?
Yeah, you can keep going if you want. I'm going to give everybody some time to catch up. So if you're through 4, go ahead and keep playing.
Sure loved you.
So you got to be pretty precise on some of these. It looks like you're going to get them, and then it doesn't work. Just tiny little movements can help. Now don't forget that they're limiting you. They're only letting you go X to 3, but you could change that. If you wanted it to go further, you could. Like change that to a 4 or a 5. See how it... Yeah. Yep. You can change the domain. You can put in a second graph if you want, a third graph if you want.
Oh my god.
Oh,
Did you get it?
Gotcha. Yeah.
Let me see.
Okay. Yep.
Nice. That's awesome. Get it?
Yep.
Good. What's so funny? That's awesome. That was perfect. So, did you change that 9?
Yeah.
Yeah. So it used to be something else, and it was either overshooting it or it was falling short, right? Good work. A lot of you breezed through fix it number 2. Some of you are still on there.
What's up, Sal?
Skirt.
Check this one out for somebody on number 2. What'd they do there? See how they inserted a red line? I'm going to see how this guy or gal's works here. It was going to miss it until it hit the red line, and then he got it. So he or she inserted an additional line right here. Very clever. Now, if you can do it even without doing that, also good. I see a couple people put in another line. This person has 2 parabolas going on. This is clever. Using that red one as a... Oh, come on. A couple of them will go. One of them goes. Clever. Clever. Good. Now, the ultimate is if you can get it with only doing one function, without even adding a second piece. Let's try this person's here. Oh, that's definitely going to get it. There it was. That was well done. Let's see. That one was Cameron's that we just showed. That was well done, Cam. I told you these were fun. Well, like Oren told me before class, we could just sit here and do this all with paper and pencil, but that's not as fun.
I agree.
Thanks, Jack.
Yeah.
I don't
Yeah. I'd like a fact check on that.
I don't think you're standard at all. Try it.
Are you honing in on it? Oh, you're going with the second line? Okay. What do you got going? Oh. Now, I think it's going to, yeah. It just, yeah. So can you move it up? There you go. There you go.
That's what I want to move.
Now, is it going to catch it? No. So how are you going to fix that?
That's really bad.
What happens if, so it's coming off and it's going too far, right? What happens if this was a little longer so it made it go up more? So change that, change that to like, yeah, well, that might be too high, but, or you could always do a decimal too. Try that. That might do it. That'll do it. Yes. Did you get number 2, Ella?
So how do you get this higher?
How do you get that higher? Which? Oh, so you're missing a number. You've got that. So if you look at the board, you've got an A, you've got an H, you have no K. You must have erased it.
Oh, I must have accidentally.
So enter a number after the plus sign. Okay, now you're too high.
Okay.
Now you're too low.
Okay.
Try, I don't know. Right now you're at 1. There, now you're at 2. Try that.
Oh, yeah.
That'll do it. Yeah, good. We might be at the point where everybody got fix it number 2. We are darn close. Alex, I don't think your number 2 worked.
Oh, sorry.
Where are you at?
It was telling me to get it done.
Oh, so, okay, you're going for a line there. How are you going to move that over? Because it's too far to the left, right? No.
No, wrong one.
Do it inside the parentheses. But if you want to move it to the right, what do? You don't add.
Yeah, minus.
Minus, yeah.
I keep on doing that.
Yeah. Keep going. One more. Well,
Of course, the wrong one.
try that.
That should work.
That should catch it, right? There you go. All right.
Sorry.
Fix it number 3. So if I look at fix it number 3, it seems to me that the stars are almost making like an upside down parabola, aren't they?
Oh my goodness.
When it clicked.
I got 2.
This is the best marble slide we've done yet.
Okay. I'll do that.
Okay, I'm going to find somebody who's clever here. Oh my goodness, what does this person have going on? Does it work? Yeah. Okay. I'm not sure what all these other ones are doing over here, but that was cool. Riley, very nice. That was the best one yet. Did anybody... What's going on here? This is somewhat clever. Are any of them going to get that? Oh no, that didn't work. But it was darn close to working. I have a vision of the marbles coming right down at the vertex, some of them falling left and some of them falling right. Would that work? Like just by chance, some go left and some go right, if that falls right at the peak? That might be something to try. Now, lots of you just got this by just scooping them. Oh. Sometimes it works, sometimes it doesn't. That seemed like a slow launch there. They didn't have enough time to pick up speed. This might do it. Once it works, it gives you a check mark up here. Here's one that's going to work. Maybe.
How does that not work?
I'm curious if anybody has turned one upside down.
No.
What's this person got going on? If this one would move up a little bit, and somehow we got to get our marbles to drop over here. So we might need a line, like a tray, to drop them off. Keep doing this for a few more minutes. I've got one more activity we're going to do before the end of the day. Did you get it?
Yeah, the one that you showed up there. Yeah, it showed that it get that last one.
It did. So I think when I do it, it feels like the marbles are slow when I do it. Like, hit yours. See, they drop nice and fast.
Yeah.
Like, the marbles are slow on mine. So did I have yours up there?
Yeah.
Yeah. It did. It showed check mark, so it showed that you got it. Several of you are through number 4. Very nice.
What the heck?
Number 4 is really similar to number 3, isn't it?
Yeah.
Jeremy, that was relatively clever there on fix-it number 4. Yeah. Yeah. Okay. If you haven't gotten through number 4 yet, that's due by Friday. I'll unpause it here in a few minutes, okay? But I want you to focus on the next activity we're gonna work on. I'd like you to open up a blank grapher, Geogebra. And what we're going to do is we're going to build what I have up on the whiteboard here. Okay? I want to build one so that instead of changing the numbers where you have to just type it in and change it, that we can do little sliders, and you can just adjust the sliders and it'll move it instead of typing the numbers in like what you've been doing on the Desmos. So what we need, the ones that I underline here, A, B, H, and K, we need to establish variables or sliders. You guys see the button second from the right? It says A equals 2. It's called a slider. Hit that button, and somewhere on your graph, just click, and it should give you a screen like that. It says, what do you want the name of your slider to be? Let's call our first one A, so it goes to A. We can slide A from -5 to +5. That's fine. Let's make the increment 0.1. What that means is every time you hit your left and right arrow button, it'll go like from 3.2 to 3.3 to 3. It'll jump an increment of 0.1 every time. So you should have exactly what I got. You hit OK, and now notice you have a slider. If you hit your pointer tool, you can slide A anywhere from -5 to +5, and every 1/10 of a unit in between. Now I'm using my left and right arrow keys to do this, which is a little more accurate than trying to use your mouse pad. Okay, so now we're going to make 4 of those sliders exactly the same as we just did. So we need 3 more. So I'm going to click on slider. This time let's call it B. That's my second one, so it defaults to B. -5 to 5, let's make the increment 0.1 again. 1/10. I'm going to hit OK. Now this time it's going to default to C, but I want to call this one H, and I want to call the last one K. Make the increment 0.1 on all of them. The last one's going to be K. The reason I use H and K is just because that's standard form of quadratic, so you'll see that like in textbooks. It doesn't have to be H and K. It can be whatever letter you would want it to be. So now I should have 4 sliders. And go ahead and get all 4 of your sliders equal to 1. That's what we'll start with. All of them are 1. So now what we want to do is we want to graph the function f of x that I have up here. You don't have to type in f of x equals. You can just start by typing it in, just like you would graph anything. So I'm going to type down in my input bar a parentheses bx minus h, and then on the outside of the parentheses I got to do caret 2 squared plus k. A bx minus h squared plus k. If you can see my input bar at the very bottom there, I haven't hit enter yet. When I do, I will slide this over, and you should have the same graph. It'll be 1 times the quantity, 1x minus 1 squared plus 1, because you have all of your sliders set to 1. Correct? So again, we've done this a million times, but you should already know what A, B, H, and K are going to do to your graph. If I start sliding A, if I make A bigger, that's a vertical stretch. See how it's getting taller and skinnier? And if I go back to 1, that'll get me back to my parent. And if I go smaller than 1, that's a vertical shrink. I'm scrunching it down vertically. And then, of course, if I go negative, it flips it over. You guys already knew that. Negative flips it over. Okay, so that's what A does for me. B Does the same thing, but it does it horizontally. Horizontal squish, horizontal stretch. Okay? And then you guys know that H, since I typed in minus H, it's minus H. So as I move it to the right, it's going to move to the right because I used a minus sign. So H is moving me right and left, and K, of course, is moving me up and down. Does everybody have a function built like mine with the sliders? Okay, your goal here now, I'm going to put them all back to 1. Here's your goal. I'm going to give you 3 points to plot. The 3 points I want you to plot are, and you'll just type these into your input bar. Let's do the point 1, 2.72. Plot that point. -1, -0.96. Plot that point. And 6, -2.08. I want you to plot those 3 points. And once you have them plotted, your goal is to manipulate your sliders until you can get your curve to go through all 3 of those points. Almost like those points are the stars and you're trying to hit them. Does that make sense? So I'm going to plot them on my screen here. 1, 2.72. That's one of my points. -1, -0.96. That's another point. And 6, -2.08. That's a third point. Okay. Try to get your graph to hit all 3 of those points. And you only do it by using your sliders. And I'll give you a hint. I pulled it off without changing my B slider at all. I left B as 1. You don't have to leave it as 1. I only changed A, H, and K. Left B as 1. Flag me down when you think you got it. One thing you should notice right away is your A value is going to have to be what? Negative. It's got to be a negative. That's the only way it's going to work. I hold the answer on this little Post-it note, so I'd like you to try it out. Yes? Oh, your whatchamacallit is like oscillating on us. You can shut that off. Maybe. How do you right-click on a Mac?
With 2 fingers.
Is it? Oh, 2 fingers. There. Somehow your oscillate turned on. Animation on. I'm going to turn that off. There. You got something over here? What'd you get? -0.4. Yeah. Yeah, very nice. Yeah, very nice. I actually had 3.4. See if that makes it just a hair better. Yeah, whatever. Pretty good. Very nice. All right. Yeah, pretty close. Now your K, you actually did it to the 100th instead of the 10th.
Oh.
It's very close. Nope, that's fine. Do you see how you're missing those 2 points just a little bit?
Yeah.
Try changing your A once. Try changing it. Yeah. Not bad. It's pretty close. It's an exercise in how good your eyeballs are for seeing it. That is really darn close. Now you did both your A and your B. Did you do that too? Don't you? Yep. So your A-B combination is different than mine, but it basically is producing the same thing. That's well done. Well done. All right. Very nice. So basically, you're just playing around with these we said A was going to have to be negative. I ended up making my A negative 0.4. Like I said, I didn't do anything with the B. The H, I ended up doing as a 2.3, so minus 2.3 in the parentheses. And then the K, I ended up doing as 3.4. And that actually goes right through all, move that over there a little bit. That goes through all 4 points, or all 3 points. Okay. So your only assignment is to finish through fix-it number 4. I'm going to unpause it right now. I forgot to unpause it after class on Monday, and a couple of you figured that out, that you went in to finish it after class, and I didn't unpause it. And then I did it later in the afternoon, so sorry about that. Finish through fix-it 4, and as far as I'm concerned, we're done with 3.5. We're skipping 3.6. So Friday is going to be 3.7. Monday is going to be 3.7. Wednesday is your chapter 3 test. Okay? So pay attention to your schedule. You should be ready to do all your quizzes, 3.1, 3.2, 3.3, 3.4, 3.5, all your Desmos. If you have a 0 in the grade book anywhere, that means you still owe us an assignment or 2. See you guys on Friday.